Hello, this is Jan Reinhardt with the BIM Forum. I'd like to welcome everyone to today's webinar about AI in the AEC industry. Is it vaporware or are we dealing with killer apps? We have organized a webinar with some very capable presenters, and we would, I'm sure we will learn a lot about uh, what is happening in industry where the AI is being applied. The format of the webinar is that this is a two-part webinar. We have a webinar today, and we have one webinar in 1 week from now, same time, same place. And today's webinar will be mainly presentations, and in the next webinar we will have more of a discussion and also an extensive discussion of how we get started with implementing AI. My name is Jan Reinhardt. I'm with the BIM Forum on the board. I'm also working for Adept Project Delivery, a BIM consulting firm. And I would like to invite some introductions here from our panel. We have Walt, Scott Yates, Michael Kilkelly could not make it today, but Min Song is here, and I would like to ask them to introduce themselves, and then we'll get started. Walt?
Thank you, Jan. Good morning to everybody. The BIM Forum, love this organization. Obviously, a massive impetus to BIM adoption within the industry. My name is Walt Terry, as Jan said. I'm Vice President for Controls and Planning and newly AI within Rudolph and Sletten, construction company out of California. And we're a subsidiary of Tudor Perini companies. We work primarily in the healthcare and in public educational work, and we kind of choose the more complex projects. It's kind of our meat and potatoes. Is if it's hard, it's ours. So we really enjoy that, and to that extent, AI has been a huge jump forward. And I'm looking forward to sharing more with that with you folks today.
Fantastic. Thanks, Walt. My name's Scott Yates. I'm the Chief Data and AI Officer with VDCO Data. I also want to extend a thank you to BIM Forum for everything they've done for the industry and also for the invite here today to talk about what we're doing with AI. I've personally got more than 20 years experience across infrastructure, utilities, transportation, life sciences, government, all centered around asset management. I lead enterprise-wide transformation initiatives centered on asset management, information governance, and system integration. About the last 6-7 years, I've been really focused on bridging the gap between capital project data and operations, enabling clients to derive long-term value through standards-based digital twin strategies, intelligent asset modeling, connected information ecosystems. Anyone who's worked with me and knows me that my philosophy for the last 20 years has been the key to change management is to make the right way, the easy way. And I think that applies to AI as well. I think my interesting position on this panel here is about a little over 8 months ago, me and Cindy Baldwin, the head of VDCO Tech, we basically decided to start this experiment of what would it look like to create an AI first AEC consultancy. And so that's what we've been attempting to do, basically learning from the boots in the ground in VDCO Tech, the operations they do every day, to create, enhanced AI-based solutions, both to help our own processes as well as help our clients and owners. And so what I'm going to be sharing today is what we've learned along the way of doing that. Some big successes, and then certainly a tremendous number of failures as well. And we'll be sharing all of
it. Okay. Hello. I'm Min Song. I am technical director at SBI, but SBI also started a startup called strategicgreen.ai. So I do also serve as a technical lead for that startup. For my background, it's mostly research background. I did research at Stanford Site Visit Construction Lab, also a sustainability design lab. Spent around 10 years at that SIP lab, and also spent in the industry mostly at construction sites, field experiences. So that is about 15 years. There is some overlap between industry and SIP because SIP likes to take the research work out to the industry and apply it in the real world. So there is an overlap between industry and research experience. And the places that I've worked at is US, obviously, and then Europe, Asia, South America. And while doing the research, I usually take a prototype that I have developed and apply that to construction sites and validate the usefulness of it. So that was until 2020. And from 2020, I started work for SBI, a boutique consulting firm. And at SBI from 2022, we start to develop different approaches and ways to apply Gen AI. And we typically work with BIM, OpenBIM, and GIS. Right now, we are integrating Gen AI with those technical foundations. And the use cases that I'll share today are around those areas. Yeah.
You're still muted, Michael.
I'm Michael Kilkelly. I am the founder of ArchSmarter. I've been trained, well, I've trained as an architect. I worked in practice for 15 years and then transitioned more into sort of BIM and consulting. And as I was working as an architect, I got really interested in automation, and mostly because I didn't want to work, 70-hour weeks that much anymore. So taught myself to program. And then again, as I transitioned into sort of more BIM consulting, I founded a website called ArchSmarter, where I wrote a lot about productivity and automation for architects. And that led me to developing some courses specifically geared towards Revit automation for people in AEC. I have since transitioned or taken a full-time role with Ulteg. And Ulteg is a consultant engineering company that focuses primarily on utilities. So we do a lot of work with renewable projects generally. And I'm working specifically on looking at automation within electrical substation design for renewable, so solar and wind projects. And so a lot of what I'm going to show today kind of is a combination of my ArchSmarter work as well as with Ulteg, where I've been looking at how I can leverage AI inside of Revit and try to find that line between, where does it make sense to use AI for sort of non-deterministic roles, and then also leverage automation inside of Revit for more deterministic. So I'll be presenting on using AI to generate Revit families from vendor drawings.
Jan, I think
Jan, now you're on mute.
Now I'm muted. Okay, 3, 4. Good. Let's get going with presenting each of your use cases. And what I would like to do, one thing is to invite everyone to write their questions in the chat window. We will collect the questions, and in webinar number 2, in 1 week from now, same time, same place. You need to register on the BIM Forum website for that, but same time, same place. We'll go through the questions, make sure all of them get answered. We'll deal with the questions, and we'll talk how to get started with implementing BIM. But without further ado, let's take it from here. Walt, you're first.
Fantastic. So it looks like my slides are up there. I'm really excited to talk to you folks. As you can see from my title slide, we're talking about building with AI. We are first and foremost a general contractor. However, we've been doing a lot of design build, and that's becoming more and more a larger portion of our work. But I'm really going to focus on the building side. What is a contractor able to do with AI? Jan thought it would be a good idea for us to go first because, we don't want any of that intimidating stuff that some of my co-presenters are going to put out here to scare you off. There's actually quite a bit you can do, and so have the kind of the dumb contractor go first makes a lot of sense. So I'm going to show you how we use AI in some very basic applications. All right. So first off, what is it? Why are we using AI? Why is it important for us to adopt this tool? Well, I mean, obviously there's a lot of hype about it. I can imagine everybody on this call has probably gotten, literally you get so many emails a day, so many messages on your socials about AI adoption, AI usage, and new tools to use AI. I know I get a lot, and my people and teams get a lot. So what is the reason for using it? Well, the fact is we have a real mess when it comes to data management, information management, and there's a lot of gaps. There's a lot of gaps in from the time that we receive information to the time we're able to respond to it. So AI tools help us to get through that really rapidly. In here, I have on the slide that we use the idea of one assistant. That doesn't mean one agent. It means that we want to create, when we're creating this space, kind of a seamlessness that when you use one AI agent or one AI tool, it feels like one assistant. So that was one of the notions that we put in place as we built. So what are some of the things we've built? So I'm going to kind of go through this slide pretty quickly. Obviously, these are the things that I just described. So our approach, we wanted to use Copilot, which is we used a Microsoft tool for this. We found it to be helpful because we already had an ecosystem in Microsoft, but there are a variety of different options out there. The main thing you want to think about is your security, grounding of your data, of your AI and data that is well governed and well controlled. So security, that type of thing, all part of the considerations in choosing your stack. We'll get into that more in our second seminar. We talk about how we got there. So here's 3 specific use cases. The first one is called the RFI Coach. It's an AI agent that improves the RFI quality. One of the things that I heard from one of my teams was that the architect was requiring us to have RFI 1005.1.2.3 and then another one, and we had all these revisions. And I thought, I raised children. I have 3 grown adult children, and I know that sometimes when they make a statement, sometimes you need to check it, right? And so I checked into it and I looked at the actual RFIs, and I could see that maybe they could have been written better. So we built a coach to help them write better. We designed a constitution for that agent, and again, I'll go into that more in the second seminar. We also created an AI detection agent. So as our teams kept getting this proliferation of AI emails and AI correspondence, we wanted to be able to evaluate that correspondence and that information very fast and get to the point. So we built that agent for that purpose. And then another one is the change management agent. So this is a major enterprise issue. We just changed the way we do change management, so we have better visibility in our BI world. So we needed to give something to our teams to be able, they didn't have to read this document. They needed to get information and extract information only when they needed it, but it needed to be the right information. So I'll get into these 3 different use cases. So the first one is RFI Coach AI agent. And the benefit of this agent is, again, that we're able to help improve the quality of the RFI. What are we going to do in it? We're going to actually pull the RFIs that are in our existing, we use Procore as our system of record. It automatically pulls those down, and then so now it's grounded in the actual data. It allows them to look at their draft RFI and ask a question about it, like, can you grade my RFI? And then probably the best part of it is you could ask for help. How do I get it to be a better agent? A better RFI. So here is the RFI Coach agent, and as you can see, I just asked it, "What's your purpose?" and it describes what it does. There is a constitution, and that's a massive document. I'm not going to bring up and show on the screen, but it can be looked at. What we do with that is we give them some standard prompts. So I'm going to start with this prompt. Now, what's going to happen with any live AI demonstration is you're going to see the time it takes for one turn. A turn is taking information from the prompt and other pieces of sentences and words and whatnot, and sending it through the large language model to retrieve results. So this can take a long time. It can be a time-consuming process. So we try to structure things in a way that allows us to be able to do that more rapidly, to do it quicker. So when I came back with this, it's saying here, well, I found a project with this ID. before I proceed with retrieving that, confirm, is this the right job? I did pick a public works project. So I'm going to confirm that it is. And the reason why I say that is because it's, obviously it's open to the public. You could discover any of this information. So now it's going to go ahead and retrieve the information about that. And it gave me another note, another piece of information here. I can't yet produce the 20 because the available search result only exposes a small portion of the RSVs. So of the CSV. So the only one it could actually verify was this particular one here. So it didn't give me 20, it gave me 1. Well, that's okay. So I'm going to ask it to grade that. So grade 27, okay, there it is. Okay, so again, this is a live demo. So again, we'll see how the agent's performing in this particular situation. So here is the actual RFI scoring. It's getting a 78 out of 100. Well, that's problematic, right? So again, I'm looking for, when I asked for that set of RFIs, I was looking for those that were in that draft stage so that we can get better at it, right? We can improve the quality of that. So what are we looking at? Maturity of the issue. So again, looking at this table, you can see there's a description of why the score was 28 out of 35. It's narrowed to a single constructability decision, that's the explanation of what we want in maturity. In a confirming of RFI, avoid open-ended design exercises. So we don't want to make the architect or AE team have to guess what we're talking about. We want to be really clear, avoid buried question and scavenger hunt anti-patterns. So we want to make sure we're getting really into that. So I can now ask it, how do I improve this RFI? So by asking that question, I can now, again, using the Constitution that we've drafted, allow the person to see, okay, here's a current version. How are we going to improve this? So it's going to say, all right, it's going to add some contract references, some contract basis for this. The RFI should include applicable drawings, details, specifications, perhaps a submittal or a coordination document, not just a markup. So again, we want to give more reference points to this. We want to give our design team some clues about how to help answer our questions so we don't end up with .2s, .3s, .4s, and that sort of thing. So again, this solution has been very, very helpful. We have a lot of young people coming into the industry, and they don't have a lot of the experience that they need to have to be able to answer questions. So, or excuse me, ask questions and ask them well. And it's interesting. I am watching the comment section. I see somebody asked if anyone's received 100% score. Actually, the answer is no, not that I know of at least. So when we built this tool, we actually designed it twofold purposes. So one, I've described to you. I've told you, okay, yeah, we use it for the project engineers to help them write better RFIs, but we also use it for the project managers. When they come in the morning, their prompt is, give me the last 20 RFIs we submitted, and then score those 20, and then they will review them to see how they're panning out, right? So we're looking for an 80 to 90%. And 90% sometimes is enough. It's subjective. There's still experience that's required, right? And that's what the PM is going to be able to look at and evaluate. If somebody got an 85% score and he or she looks at it and says, okay, this is enough information to answer the question. They're doing it in the morning for the submitted ones because typically we have, if it was submitted yesterday, we have time to correct it, right? You still have, within a 24-hour time, you could go in and revise your RFI wording. And typically our design teams they got so much going on that they don't have time to, they won't be looking at it that quickly, unless we make it extraordinarily urgent, in which case we want a PM to look at it before it goes in anyway, right? Regardless of the workflow. Okay, so I'm about to transition now. We're going to take questions, I guess, at the end of these things. So at this point, I want to talk about the AI detection agent. So again, this is a very simple agent to build. In fact, it's one of the things that I think we built very first thing. So what does that look like? AI text analysis. Okay, so I have an email that I wrote to myself this morning. And so I wrote it, and then I was going to show off the power of 365 AI which Microsoft 365, which could reference my emails, and I wouldn't even have to paste it in here. But instead, I found that it was a little slow at doing that. So for this presentation, I just pasted it in here. So I'm saying I received the following email. I want to run an AI detection analysis and sentiment analysis and summarize it, right? Because, yeah. So here it is. It comes in. It says, I hope you're having a productive week and your respective work streams are progressing smoothly. It goes on to talk about different things, some concerns, but it's just lengthy. It's long, and I don't really know what it's trying to say. So here it is. I get an executive summary really quick, and again, like because AI makes words so cheap now, like AI literally can make people who are at one time used to be succinct, now they're verbose, right? And so how do we deal with that? So I want a quick thing, structured analysis, formal accountability escalation message. That's what it is, right? Apparently I haven't been doing my coordination tasks on time. And that's what this is telling me about, right? So there's some things in here about AI detection. And it's a very high level, medium high. So it's very, very likely it was generated with AI usage. Why do I care about that? Well, there's a lot of reasons I care about it. Number one, I want to see how the people that I'm doing business with are preparing their emails and the way that they're processing them. But more importantly, what I found from AI generated things is that they often are not specific. They don't contain actionable things for me to do. There isn't a specific action required. It's just going to slow me down and slow my teams down reading this, this word salad of what's going on. So, and it tells me what's detected here because we wrote a constitution for this AI agent. It's a highly polished corporate language, remain aligned, return to our collaborative, predictable workflow, maintain project performance, all that kind of stuff. It's a formulaic structure, so that says it's probably AI, balanced and symmetrical language, etc. I want to get down to lack of personal specificity. I think that was pretty important too. So there's some signals about human authorship. So there was probably a human controlling the AI. It wasn't just an automated AI message. Sentiment analysis. This is important, right? Like, is this person really started out with, doggone it, Walt, get your stupid coordination task done. I'm tired of your stuff. Did they start out with that in their email and then said, all right, AI, make this better? What's really happening here behind the scenes? Well, there's a high concern level, very emotional, right? I want to know that, but I want to know that for a variety of reasons. Like, do I need to make a phone call? That would be our training to our people. If you see concern level high, that's a phone call, right? Let's talk to this person, a Zoom call, a Teams meeting. There's something I'm doing and I need to get from there before it gets worse, right? I want to catch that early. Frustration, it's moderate to high, right? Disappointment, moderate. Assertiveness, it's kind of high, right? Somebody's flexing. And hostility is low, though. Where did that come from? Well, that's AI. AI doesn't like hostility. So it'll neuter it down. But that doesn't mean it wasn't there initially. There could have been some, I'm going to get in my truck and drive over to your office, Walt, thing before the AI took care of that. So, okay, this is the sentiment analysis one. And then I want to the AI detection agent. Now I want to talk about one that's super near and dear to my heart. And that is the change management 2.0. So change management in an organization is one of the hardest things we do. Change orders are very, very different workflows on different projects. We have different customers, different individuals. And so the reality is I'm muted.
Oh, Walt, just go quickly through it, just to give the rest of the presenters also a little bit of time.
I'm sorry, I was going too long. Okay, thank you very much.
And then we can, in webinar 2, expand on details.
Okay, very good. So this is the Change Management 2.0. What it does is it uses the already existing guidance that we prepared and allows the active user to use the AI agent to answer questions about, like, hey, I'm a PE, new on this job. I don't know how to do this, or I'm in Procore, and you actually describe where you are in Procore, it'll tell you what to do next, what to see on the screen, what you do next in the action process. All right, well, thanks everybody for your time. I apologize for going a little long there.
Fantastic. Hey, thanks, Walt. I'm really glad you went first for a couple reasons. One, you hit the time limit first, so when I do it, it will be I won't be the first one to have done that. Also, I like how you went deep on some of your use cases. What I'm going to be presenting is a little bit more broad across the organization, the different areas of the organization that AI has infiltrated, and kind of our philosophy around that. So it's nice that the audience has kind of already seen some of the specifics of some of how these types of solutions work. So I've already done my introduction, so I'm not going to go back through that. The ground rules for what I'm showing you here in my next 10 minutes are on the screen. Everything you're about to see is running today in production at our firm. Every use case comes with the lessons it taught us, because I think, a trench report where we don't share the casualties is just an advertisement, and that's not, what we're here to do. Before I do jump in, one caveat, I'm going to be sharing some failures here and some costs, but we're very much all in on AI. But, we believe and we understand that it's not a magic bullet that you just buy off a shelf. It's an organizational journey, and it changes how you operate one step at a time. And so I'm going to try and reflect some of that journey that we've had over the last 8 months. What you're going to get from me today is basically passion and also honesty. Let me see if I can figure out how to advance the slides. Perfect. All right. This one's a little bit of an eye chart, but that is on purpose. This basically shares what we've done at VDCO Data and VDCO Tech across the last 8 months of just immersing ourselves in what it would look like to think AI first on our biggest challenges and problems. And so you see 26 solutions between November of last year and June alone. Everything in blue that's above that center line is where AI is actually doing work. AI is embedded in those solutions that we're using. And so a couple key examples from there. Vault Miner is a tool we built. It reads piles of construction documents, PDFs, CAD drawings, spreadsheets, basically all the messy stuff that you get at handover, and it's able to extract asset inventories out of those for downstream activities. Cortex, one of the solutions you'll see there, it's a second brain. It turns every recorded meeting that we feed into it into direct action items and a searchable knowledge base, and there's no human in the loop in the mining of that data and the organizing of that data. And so all of this, everything above that line, builds up to our first virtual employee, Nathan Bildright, and I'm going to talk a little bit more about him in a couple slides. Now, below the line, everything in that amber color, this is normal software, but it's software that we built internally using AI assistants, right? So most notable is Insights. That's the big one. It's our CRM system. It also does project management, timesheets, and invoicing. So we are literally generating our client invoices out of this homegrown CRM and project management system. And I think the amber row down there matters more than people think. This is a very new and real opportunity, particularly for small firms where, we built an entire back office enterprise suite, and we built it in weeks, not quarters or years. And we built it on our own design principles, with data interoperability being first and foremost. So now the big lesson on what you're seeing on this slide is we didn't buy a single AI platform. Our philosophy is that we build AI capability into our people, and we give them tools. And so one small brick at a time, we increase that capability of the organization. And our belief is capability you build into people compounds. A subscription you buy from someone else just simply does not. Right? All right, so let's dive into some of these specific solution areas. Skills library. All right, this is where I think most of the value is, honestly, for us. Between the big, frontier AI models and the automated agent systems, there's a quieter layer, and we think it's where most of the transformative value is, and it's building AI capability and skills directly into the employees of the organization. So, what we do, the mindset we're trying to instill here is that if a task is going to show up at our firm more than twice, it's something we're going to do again, then we really want to think about how we can turn it into a saved skill, similar to the solutions you just saw from Walt in the last 10 minutes. But it's essentially a written playbook, a saved prompt, if you will, with templates and other components. But it's a written playbook, an SOP that an AI model can use to execute a repeatable task on demand. And we've built up a library of 30 plus of these things, and some of the key ones are on the screen here. And how did we get here, right? How did we get to this library of skills that people can use for these various tasks? And so this is where I'm going to be honest up front. It's not equal AI access across our firm to all. We run what we call a scout-led model. So we have a handful of power users that we allow to independently experiment. They get, some guidance and some coaching and some guardrails, et cetera, for support from me. But we basically empowered them to build their own skills that help them in their daily work and help their teams. And the end result, the immediate result, is the scouts themselves are reporting, 40 to 60% personal productivity gains on tasks that they have now brought AI into the equation. And so my job then becomes mining these skills that they're creating for themselves and seeing value on, and figuring out how to turn them into something that the entire enterprise can use. How can we make them under change control, secure, using the right data, all that stuff, and deploy them back out to the larger organization. But you're seeing actually some of the scouts we have right here on this slide. A great example is Paul. He's a scheduler on our team who taught himself Claude. He built a Monte Carlo schedule risk analyzer, and he ran 10,000 simulations against an 8,000 activity project schedule on a live project. And his P90 forecast landed close to what the job actually did do. And so, what I say here is when the scheduler is building his own AI tools, this is no longer just a novelty, right? This is a way of working within our organization. So how do we spread that, right? So if we're working with the scouts, how do we spread this to the rest of the organization? And that's where the biweekly AI open forum comes in. So this is a forum that I host every other Wednesday since January. The whole firm is invited to it. And basically, it typically starts with me providing some sort of a lesson, but ultimately gets into a discussion of just what people are doing, what they're trying, what's working, what's not. That can be work related, can be personal hobby related. But the one standing rule that never changes: if you build a prompt that works, you save it and you share it. That's how we grow this library of capabilities. And again, it's my job to make sure that they're safe, secure, and enterprise grade. But the lesson I want to leave you with in this space, other than just empower your people, is that the majority of repeatable skill definition, creating these things, is capturing the failures as you use it, as you test it, and as you use it. It's imperative that when you give instructions to an AI agent, the majority of what you're going to do when you get an output back is tell it everything that's wrong and needs to change. It's really important that you capture that stuff and build it back into the instructions of the agent. In fact, a lot of our skills, our defined skills, are a relatively simple process and instruction with some templates, and then a really long list of rules that we have learned in evaluating the outputs. And we found that works really well. If you don't capture those failures, you're certainly doomed to repeat them on future cycles. Now, we are also using AI agents. We kind of got to them organically. Nathan Buildwright, you're seeing on the slide here, he is an employee of VDCO Tech. He has a company email address. He has a Box account. He has an employee ID. We actually even have labor rates for Nathan Buildwright. But his current job, Nathan's job specifically, is to be an onboarding co-pilot for Alexis, who's a new hire in our organization. Nathan reads every email that's sent to him, every Teams message, the attachments on those, anything he's copied on, and he builds a task queue. He monitors the tasks that are being assigned to Alexis, and what's important, what's next. He also takes all of the knowledge that's been provided to Alexis and builds that into a wiki. And we're going to be able to use that wiki to onboard other people in the future, create a flywheel there. Every morning, he sends a prioritized brief to the people to her and the people responsible for managing her work, so we can monitor the development that's happening there. And he's done that every single day since May 6th. Every day, every business day since May 6th, he sent out that email. Now, on June 17th, we started hiring Nathan's siblings. We actually have an entire team of BuildRight agents now. We've got one, Rebecca, who is learning the marketing and billing ropes from our COO, Sandra, in the hopes that we can start to offload some of her repetitive tasks to Rebecca. And then we've got three, Marcus, Patricia, and Elena, who are embedded on live client projects, and they act as project historians. Similar to the onboarding co-pilot, they're just collecting open tasks. They're collecting facts and decisions about the project, so they're easily accessible in the future. We can use the project historian as an assistant on future jobs. All right, so lessons learned, some of the lessons we've learned in the agent space, because it is a little bit different than, what I was talking about, the skills library. First and foremost is, tuning an agent is never done. It's like an employee. You're going to continue to manage and develop them over time, just like you do an employee. Nathan's early briefs were overwhelming. Derek, one of our executive VP, he told us so right off the bat, in exactly those words. And an agent that over communicates erodes trust just as fast as one that under delivers. And so tuning that noise filter in this particular case was important. But there's all sorts of aspects of that agent that need to continuously be tuned and refined once you release them out into the wild. The other major lesson we learned, this is a personal one for me, is when we first tried scaling Nathan, so we knew we wanted to set up more agents, the idea was, let's copy. Was that?
2 more minutes.
2 more minutes? Okay. Appreciate that. We tried scaling and we just thought we'd copy him and redeploy. And very quickly you realized that's a change control nightmare. So we pivoted to creating a platform of developed capabilities, skills, essentially a toolbox. And then we created a configuration layer where we could define an agent profile and just spin up a new agent with the appropriate capabilities, with a new identity and context. And so, you really got to think about how you're going to scale these capabilities across your organization. All right, final area I want to talk just a little bit about, everything we talked about so far was work we've done on our own firm. This has represented a real client work that we're doing with AI. On the left side here, you've got a West Coast seaport. They wanted a virtual model of a 50-year-old facility. It's basically a scan to BIM effort. We had over 2 gigs of records mined from 50 years of projects on this facility. I mean, exactly the messy type of data that everybody gets in these situations. And our pipeline was able to pull the asset instances out of that pile and deduplicate them into a clean list, right? Very cool. Cost us about $8 to do that versus months of effort. Honestly, it's something we probably wouldn't have even attempted to do without AI. But there was still a huge miss, a huge break. We wanted to compare that data to field verified data. So, maybe something controlled in the CMMS or captured from the scan, and the data simply didn't exist. And so, the big lesson there is, you can get huge time savings out of AI, but you can't outrun missing data. If the data's not there, it just simply isn't there. All right, let me wrap up because I think this is the most important slide in the whole thing. Happy to talk deeper on all the things we're doing in next week's session. But the tuition bill, right? So what did it cost us? This is the recap here, what 8 months actually cost and what it bought. And so the honest bill has 3 lines and they're on the screen. Take these a little bit, you got to kind of right size these to your organization. We're a relatively small firm. So think of this as what, the cost or involvement might be at a department level or a team level. But the one thing no vendor demo is going to ever show you, about half of my time since November has been dedicated to this role, to enhancing AI, to enabling AI at our organization. And that dwarfs, obviously, everything else on the bill that I'm showing here. We had around $10,000 of true IT investment in software, hardware, hosting, that sort of stuff. And of course, we have the investment cost of doing those meetings that people attend, that our employees attend. So that's the cost that went into all of this, just very realistically. But what did it buy? I mean, everything I've shown you so far, right? 26 solutions that we have in production, 5 agents actively working on our team, 5 new employees, essentially in the org chart, 30 plus reusable skills that save us time on all those tasks. And then we've got individual scouts, a handful of scouts measuring 40 to 60% gains on their AI touched work. So it's very real return on that investment. We would do it again in a heartbeat. The failures also, cost us and taught us, right? And so the full list is there on the screen, but 2-second brains died before we actually had one that lived, right? We had to go through those growing pains to figure out what would actually work. We also had a situation where we were trying to create a report from quotes off a mural board in a workshop. Our audit found only 46% of the quotes were verbatim. We figured out why that was. We fixed it. We, re-extracted and produced the report. But, it just shows that the human in the loop judgment is always still incredibly critical in those lessons learned. All right. All of those failures brought us something far more valuable than the solutions themselves, and that's experience. My final thought here, none of this is magic. There's engineering behind every good AI result. I went over. I apologize, Jan. I tried.
Scott, we should make this a day and a half instead of an hour for the webinar. Thank you for this incredibly awesome report on your journey. Michael, you're next.
Great.
Thank you.
Let me grab my presentation. Okay, I have it queued up. I'm just I'm not quite sure. Oh, there we go. Great, thank you. All right, so I'm Michael Kilkelly. What I'm going to be talking about today is just a single workflow. So I'm going to dive into this specific workflow that started as kind of a curiosity of mine. And so I'll be talking through kind of the steps that I followed, and really the end goal was to generate Revit families from vendor drawings. And this is a real pain point at Ulteg. So we do a lot of renewable energy projects, and oftentimes we're working on the substations for those projects, and we will get equipment, the specific vendor equipment, late in the process, and we are then required to bring that equipment into our Revit models. And this is critical in that, we need to confirm clearances. There's a lot of volatility in terms of getting the equipment. Oftentimes the lead times are really long. And then if somebody can procure a transformer faster, then that's the one they're going to use. So oftentimes really at the end of the job, we're getting these equipment drawings in and then have to very quickly model those accurately and bring them into Revit so we can just check everything out. So again, this started earlier this year. I was curious, I'd been using Claude quite a bit, and then I was just wondering, well, what can Claude do with an image? Can it read it? And if it can read the image, can it generate a Revit family? So this was a series of prompts where I'm just uploading images and saying, Claude, what can you tell me about this? And Claude actually can do quite a bit with an image. So I started off with some furniture models, thinking that's going to be something easy, and having some prompts back and forth, asking Claude to generate data files. And I'll talk about the data files because that's a key component. But what started as a series of prompts and then evolved into Claude skills became a kind of standalone Revit add-in. So this is, and I apologize for the dark, it's dark on dark, but this evolved into a Revit add-in, which I've open sourced, which is called the Family Fabricator, or FamFab for short. And what it allows you to do is upload an image into the interface, and then I can provide some additional context. So here I have the Eames bookshelf. I upload just a single image of it. I give it some dimensional information that I copied from the Design Within Reach website, just giving overall dimensions. And then I can choose the specific Claude model that I want to use. So FamFab is using Claude on the back end, and it does require you to have a Claude API key. So again, the software is open source. You bring your own API key. That way you control your costs. And it's been interesting too, just seeing the evolution of models. When Claude Fable 5 came out, I was really excited. I tested it and it actually worked really good. And then it got shut down. And so I was back to Opus, which didn't have as good results. And then Fable 5 came back. So it's like, it kind of, you're playing with the capabilities that are available in the various models, and those are changing. And there are also costs associated with it, which I'll talk about in a little bit. So this is my prompt: image, additional context. I choose a model, and then I click the generate button. So this will takes a few minutes. Like I'm clicking a button and we're seeing the result, but it generally takes, I'd say, 2 to 3 minutes to get results back. What Claude does is it returns a data file. And then this is a viewer. So I'm not dumping that data file directly into Revit. I want to look through this. Like, does this look okay? It looks pretty good, but there's some kind of key details that are missing. And Claude doesn't get it right 100% at a time. There's kind of a process involved in that. So in this case, I'm not in Revit. I'm looking at this viewer. The viewer itself is it's a 3JS web page. It's a single HTML page that's embedded in here that Claude generated for me. So the intent was I can send a prompt to Claude, I can get the data back, I can inspect the data, and when I'm happy with it, then I will bring it into Revit. So going back to what Scott had said, and I think we'll all probably mention, is just that idea of human in the loop. So this gives me an inspection point. So from here, I can go ahead and I can make some corrections. I have a refinement field. I can add basically, fix this, do that. And I can click refined. It's going to send the data file back to Claude and then give me another result that I can inspect. I'm like, okay, that actually looks pretty good compared to the original. There's some things I may want to tweak, but we're good with it. I'm going to go ahead and click this generate button, generate family, and that's going to switch, and it's going to take that data file and it's going to generate that, use the data file inside of Revit. So I'm not using an MCP server or anything like that. I'm actually having Revit use a deterministic script file essentially to generate the family in Revit. So I'm using Claude to make the determination and generate the data file. Then once I have the data file, that's determinate. So I can then run a regular automation script to build the family. So I can take a look at that. That looks pretty good. It's generating these reference planes. It will create the parameters, but it's not linking the parameters. So that's sort of a future on the to-do list. And then, I look at it, that's not bad. It's based on Claude's assumptions on the dimensions, but I did give it some context for that. So that was a good sort of experiment in seeing it through. And again, as the models evolve, the capabilities get better in terms of this image to Revit family workflow. So I thought, great. Let me feed it some drawings because drawings are going to be much easier. There's more information there. And it turns out drawings are a lot more difficult. Photos are easy because Claude can go through that and make its own sort of assumptions. Drawings, much more difficult. And again, going back to, well, why is that? Well, the photos, aren't necessarily, they're not precise. So again, there's some wiggle room that Claude has in making some determinations. It's very good at, it would pick out exactly the piece of furniture. I didn't provide any context of what this furniture was, but it could generally figure it out. And it would, particularly Fable 5 was really good at nailing it, like who the manufacturer is, what the model number is, all of that. And it could get some of the dimensional data. But, its precision is not super critical. One image, that furniture, that bookshelf, that's maybe 30 elements inside of Revit. When we start looking at electrical transformers, that's a whole different animal. So precision is important, and the detail level is really high. So in this experiment, this was actually done during a hackathon at Alteg. I had already had my image to family workflow. So I said, okay, let's see what we can do with drawing. So on the left-hand side, this is just a raw DXF that we get. It's a general arrangement drawing of a transformer. I fed this into Claude and the results were really horrible. As you can imagine, it didn't get anything right. And so I started going back and forth. And on the right-hand side, this is a cleaned up DXF file. So what I did is all of the features had to go on their own layer. I had to strip out all the extraneous information. I had to add additional dimensions. And it's really as a human, I can look at that drawing and I can understand, okay, these are surge arresters. We've got an oil containment tank. Here's some supports. Claude has no idea. It's just lines, and they're unstructured lines. They have endpoints. They have, they have lengths and all that, but it doesn't know what they actually represent. So there was a cleanup step involved in preparing the drawing to be machine readable. And again, going back to this idea, Claude's not building the family. There's no MCP. It's not interacting with Revit. It's really writing a structured specifications document. And then I have code in Revit that's going to read that specifications document and generate the actual element itself. So there is a kind of a break between what Claude is doing versus what we're actually doing in Revit. So this is a look at what that specifications document, it's a JSON file, so JavaScript object notation. I worked with Claude to develop what that schema looks like, but essentially it's breaking down all the elements in the DXF file, organizing them into this format, and it's giving it, you can see, our start and end points are all, it's sort of mapping this out to specific coordinates and origins. And so it's building a data structure from the DXF file. That data structure is not specific to Revit. In fact, I can bring it into a viewer like I did with my furniture, and I can actually modify and sort of interrogate it. Now, this is the finished version of it, so it looks a lot more complete, but it took several iterations to get to this point. In fact, these are some of the iterations. So in the first one, like the bushings here weren't sloped. We got the wrong tank orientation. And then we had, this is looking a lot better, but our arresters aren't shaped the right way. And then we've got some bracket issues here. So I'm iterating with Claude and saying, okay, here's the feedback loop. I want to make sure that, I want to make these corrections, and then let's get and refine this and get to a better place. So in the end, when I click that generate button, this probably took about 8 or so iterations going back and forth. This is the final version. And I can actually compare this against the DXF file and ensure that, it is dimensionally accurate based on it. So this is, again, a good experiment in looking at how we can leverage AI in that capacity. What I'm looking at now is, okay, how can I automate the drawing prep? How can I make that process a lot easier? And then also updating the FamFab. What I showed as far as the DXF and the actual drawing was done a combination of some scripts I wrote and Claude. And so I'm looking at incorporating that into Family Fabricator. So I'll end here. If you want to experiment this, upload an image into Claude or whatever LLM you're using and ask it to describe what it sees. And then you can do the same thing with the DXF file, and you'll get a feel for what is machine readable. And if you want to try out the Family Fabricator, I had a link there. But we're good. We're out of time.
Michael,
but you can go to my
I see
website.
a lot more webinars in the future to follow what you're doing. It's incredible. Min, you're next. Thank you, Michael. And take your time. We will run over the hour, but it's well worth it. And this is fantastic content. Take it away, Min.
Okay, thank you. So I have 2 logos at bottom right. One is SBI and the other is Strategic Green.ai. SBI, we started a consulting firm, and now we have a venture startup, Strategic.Green.ai, which is more focused on providing solutions that are using AI. And I guess the differentiator that we have, a couple of problems that we are trying to solve is, I guess, 2 things. First, we're converting unstructured data into structured data using AI because the construction industry and built environment sector has a lot of unstructured data, like images, drawings, 2D drawings that we talked about. But perhaps more important, the second part that we are trying to solve is harnessing or controlling the output of AI models. So when I say AI models, models like Claude or Open AI, ChatGPT, those are commercial AI models. But the thing is that when we ask AI to do complex tasks, the accuracy level is not 100%. And most of the time, if it's a really complex task, the accuracy level may be 80%, 85%, and the remaining 20% is rather, random. Randomness is the issue that we constantly run into. And in the professional industry, providing output or results that are not 100% does, kind of hit you back. So our main objective is how do you improve that and bring that close to 100%. And how we do that is in this diagram, mostly what you see at the center, the AI layer and the inputs and outputs that So on the left side, you have the unstructured data from the industry, like drawings, images, or PDF files. And at the center, we have the AI pipeline that we have developed. Of course, the main, the very center part, the AI layer, was LLM and VLM. Those are mostly tools like Claude or Gemini. So those are not the ones that we have developed. What we are building is how ways to control the inputs to those LLM and VLM, and ways to control the outputs that's coming out of those LLM and VLM. So first is controlling the input, and a couple of examples are, given a certain task, there are certain formats of files or formats of data that AI works better with. So how do you change the original format of unstructured data into format that operates better with the AI model that you're going to use? So that's one of the things that we're doing. And after the output is generated from the Claude or Gemini, how do you refine that? In a couple of years ago, what we tried to do is training the model or fine-tuning the model. And the downside of that is it requires a lot of human in the loop and labor investment, because you have to do a lot of labeling, and that does take quite a bit of time. I'm not saying that you can totally minimize or eliminate human in the loop these days, but the question that we had is, how do you automate that? Is there a way to automate the tasks that used to be done by human, like labeling? So what we do is we work with confidence scores and validation factors, like matching text with the original data that is input to the AI model, and ways to correct the output if it's wrong. So there is a performance tracker, and if the performance doesn't seem to be up to the level of 100%, then it will go back to the pipeline, to the original position, and it will start to update the instructions or skills. Some people say those are skills. So that's the main pipeline that we have. And using that, the core pipeline on the right side, those are some of the use cases we have: finance and contract, sustainability, carbon emission assessment, construction site progress management, and so on. For today, from the right side, I will pick a couple of examples. First one is application for payment. And in this case, the AFP documents in PDF format were collected from different Department of Transportation, so Caltrans, IT, Iowa, DOT. Sometimes those are in PDF format, but sometimes they could be in a database. But even if it's in database, 50 states use different formats of data. So how do you kind of bring those together and put them into a consistent data format was the challenge that we had. So the second step is the AI pipeline that you saw. So that's where the self-correcting improvement, algorithm work with the AI. And what that does is putting that PDF data or different types of database format into a consistent financial open data format, which is XBRL. And once that XBRL data is generated, then we integrate that with BIM or IFC by using BSDD. And this is the example of the application in operation. On the right side, that's more of a mock-up, but on the left side, that's something that is available today, and we have a prototype for that. So that converts application for payment into XBRL format. And each AFP, application for payment, is contributing to drawing the line, the red, the orange line, or the blue line on the right side. And by using BSDD, we are also linking that to BIM. So from insurance companies' perspective and surety companies' perspective, this can really help you to assess the reliability of different contractors if those XBRL data format can be collected on a national level. So that's one use case. The other use case is BIM-based carbon calculation. So when you have BIM objects, material type is really important to assess carbon emissions of a project. But you will often see that material type is missing from BIM objects, including the supplier information. So how do you infer the specific type of a material and then also the supplier information. So this is a case we did with a JTC, a Singapore agency. We had a warehouse project where we ran 60,000 BIM objects, ran through a pipeline that you saw before, and filled in the gap where it provided the inferred material type and supplier information. So before using this method, the manual method of checking the material type and inserting the material information to Revit objects, that took a pretty long time. But after applying this method, it really drastically reduced the time for that. And this is the actual web application in operation. So the input is Revit converted into AEC model format, and the information that you see on the right side are the inferred information. So specific material types. You have different types of concrete, C45 grade, C60 grade. Those are inferred by the AI. The reinforcement steel, those are parametric calculation, not really by AI, but those are in general outputs that are generated by AI. And this is the pipeline. I won't go into the details, but we use AEC OpenShell to extract the data from them and then serialize that text information into the AI with other information like a structural engineering manual. Third use case is converting utility bills data into a consistent format. Granted, there are thousands or hundreds of tools out there that does OCR and uses sometimes OCR and AI to extract information. The delta of those approaches that it tend to extract all of the information that is in the utility bills. In this case, we are finding common denominators. If there are 15 items that are consistently present across different types of utility bills, those are the targets that we are going after. So it converts unstructured data into 15 data items that is consistent across the portfolio. And this is the actual web application that is in operation. So once you have that consumption data coming from the electricity bill, water bill, gas bills, it converts those amount into scope 1, 2, 3 carbon data, and then it's put up on this dashboard, which allows you to compare the emissions between different assets that you have or different buildings that you have. And again, that consumption, average consumption per tenant space can be mapped to a color code that you see here. So the orange colored means that the energy consumption is relatively high. The blue means that the energy consumption is relatively low for a certain tenant. These are some ongoing questions and debates, but I think some of these we can discuss in the next seminar. Okay, that's all I have.
That was fantastic. I would like to thank all the presenters for their fantastic contributions today. We had way more material than we could have covered in 1 hour. We have good news is we have part 2 coming next week, same time, same place. Please, audience, submit your questions here, and we will also put a link on the BIM Forum website if you think of additional questions. It's very interesting for us to see where your mind is going, what questions you have, and I'm very encouraged and enthusiastic about the format and the content and the audience. So this will be something that will be ongoing, I would believe. So thank you to the presenters. Thank you for to the audience for taking the time and joining us today. We will continue next Thursday, 12 p.m. Eastern Time. Please register on the BIM Forum website, submit your questions. Thank you and have a great day. Thank you, everyone.